Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of scientific notation. This is standard 8.2c in the great state of Texas, and we are using item number 9 of the 2022 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this problem, and it doesn't look like it's asking us to use any type of operations. Let's take a look. There are a total of 463,100 books in a library. What is the total value? What is the value of the exponent? Well, there is no exponent. When this number is written in scientific notation, and we just simply need to record the value of that exponent in our answer document on the bubble chart. So let's take a look at what we know about this, because it is a place value problem, but in 8th grade we know all about place value. But here's the interesting thing, is when we are in 8th grade, we're learning about this form of writing really large and really small numbers called scientific notation. So what you do is you get a number, and here's the rules of scientific notation, is the number has to have just one digit in the ones place, so one whole number. We're not going to go to the tens, hundreds, or thousands. You can have as many digits as you want to after the decimal. Typically, it's not going to be a whole lot. No more than 3 is normal, but you can have as many as you want to. But here's the deal, is you can only have one number that's to the left of the decimal, one whole number, and it's going to go in the ones place. And so what we need to do is we need to take this number and we need to transfer it into that form. Now obviously, if we're going to just suddenly move the decimal, because the decimal in this number is right here, and that's going to change the number. 463,000 is a lot different than 4 something, right? So scientific notation, what it does is it says, you know what, we want to make there be not so many zeros in our answer. So we're going to multiply it by 10, and then we're going to raise it to an exponent, and that's what we're looking for here. So first, let's look to see what we were to do if we wanted to make this a decimal that has only one whole number. Well, we'd put it right there between the 4 and the 6. And so we would go 4.631, and we're dropping off zeros, because that's the whole point of our scientific notation, is you want to drop off zeros. But how do we get from our original number to that 4.631? Well, the decimal is in the ones place to start with, and you're going to think, I moved it over once, twice, 3 times, 4 times, 5 times. All right, so if I wanted to go from 4.631 back to 463,100, I need to move the decimal 5 times, which means I need to multiply it by 10 5 times, or 10 to the 5th power. And that's how you work scientific notation. So if I wanted to go from this form to the original form, I would do this. Multiply by 10 to the 5th, so I'm going to move it 1, 2, 3, 4, 5, 2 blanks, 2 zeros. There's my original number. If you're going to a decimal, you just have a negative exponent. So if this were like 0.0004631, right? 1, 2, 3, 4. It would be 4.631 times 10 to the negative 4, because when you multiplied this back, you'd have to go to the left 4 times rather than to the right. So that's how scientific notation works. But we need to find out how we can transfer this to our bubble document, because if we don't do that correctly, everything is incorrect. All right, so we've got a answer document, 2 digits to the right. We've got, I made them not proportional, but that's okay. 4 digits to the left, and your answer is simply 5. Bubble in the 5, and you're good.